So let's start our journey here at looking at simple carbohydrates. We have simple and we have complex. When it comes to simple carbohydrates, we have two different types. We have monosaccharides and disaccharides. And if you just break the word down into its component parts, you can figure anything out in science. Okay. Mono means one. Okay. Saccharide means sugar. Again, this is your most basic, simplest sugar that you got. It consists of only one molecule. Okay, so if you were to look at these things, here you go. This is what one molecule of glucose looks like. Fructose and galactose. These are my three monosaccharides. You should probably be able to figure out which one's a monosaccharide, which one's a disaccharide, and when we look at the polysaccharide, be able to differentiate those. Okay. But glucose, this is your primary fuel. Okay. This is your primary fuel. This is what we're going to be talking about when we get into metabolism. Glucose is the primary saccharide, the primary carbohydrate that's used by the body to make energy. Okay. As you can see, it goes by other monikers, dextrose, blood sugars. Okay, when you talk about blood sugar levels, you're talking about glucose levels. Okay. Dextrose, you can see that as a supplement. Some people will have dextrose as a post-workout supplement aid. If you've never done dextrose, it's pretty intense because you're just flooding your body with sugar. And if you're somebody who doesn't eat a whole hell of a lot of sugar, oh man, I did it one time just to kind of see. I thought I was going to have a heart attack, man. All of a sudden, I just got super hot, super flushed. My heart started racing. I never used it after day one. Threw the rest out. Try to give it away to people. But it was not for me. But dextrose is like the supplement. So if there is a supplement person that you're kind of following somewhere, and they have a workout plan, they say take dextrose, this is what they're asking you to take, pure glucose. It's pretty intense. Fructose is another monosaccharide. It's found basically in fruits. So fruits and some vegetables, but think of it as your fruit sugar. Okay. Again, glucose is primarily used, but I mean, if you consume fruits, you get fructose, and that's okay. Your body utilizes that as well. It has to go through a few more steps in the process. Okay. But it can be utilized by the body. It has to go to the liver. Okay. There you can kind of see most everything goes to the liver and gets manipulated a little bit. So does this individual. Okay. So when you eat that apple, when you eat that fruit, we convert it ultimately to glucose and yada, yada, yada. We make energy out of it. So we can utilize these. It involves, there's just a vast number of steps that we're not going to get into. We're going to just be looking at glucose primarily. The last of your monosaccharides is galactose. And galactose is not really common. The biggest way that we would get galactose in us is basically from milk. As we'll look at disaccharides here in a second, and you'll see it's glucose plus galactose. So that's where we would get it. It's not very common. Really, the most common food that you would find it in after milk is galactose is found in chickpeas. So if you do consume a lot of chickpeas, you get a lot of galactose. The body doesn't utilize this at all. It has to convert it to be able to utilize it. And we just convert it into glucose, whereas fructose can enter in through the metabolic pathway, but there's a lot of tinkering and manipulation that has to go with it. So galactose of the three, not really the biggest in providing us with energy, manipulated, broken down, converted into ultimately glucose. Again, glucose is your primary number one monosaccharide. excuse me. In here, you can see what they look like. You can see they all kind of have the same number of, excuse me, of carbon atoms. It's all carbon, hydrogen, oxygen. So these are organic things. But it's just the placement, the orientation of those carbon atoms that make it unique and what really give it its sweetness flavor in the grand scheme of things. Another simple sugar are disaccharides. So simple sugars are both monosaccharides and disaccharides. They are both. Okay. Again, break the word down. Di means two. Saccharides means sugar. So these are two sugar molecules strung together. What does that look like? Right here. Okay. Two glucose molecules strung together. Okay. Two monosaccharides strung together. Two sugars, two monosaccharides strung together. We have three of these: maltose, sucrose, lactose. You've probably heard of lactose. That's your milk sugar. Okay? That is your milk sugar. Consume milk, there you go. Lactose is what you get. And then the body breaks it down and we get glucose, and there's Mr. Galactose, right? And again, manipulate it and use it. Maltose is going to be, of the three, the most potent provider of glucose just because of what it has. Two glucose molecules, and that's what you're seeing right here. Okay, glucose 1 plus another glucose gets you 2. So of the three types of disaccharides you have, this is the one that really provides us with a buttload of sugar in the grand scheme of things, just because of its chemical makeup, chemical structure. It's your malt sugar. It is an intermediate product of starch digestion, so we will see a lot of maltose when you consume starches. Starches are a complex saccharide. Sucrose is your table sugar. Okay, it is glucose and fructose. This is the one that's generally considered safe, or generally recognized as safe, GRAS, by the FDA. So we can use this. Okay? We can add this to dishes, and it is generally considered a safe, consumable product. The stuff that I like to get asked is, who makes it? Okay? What comprises maltose? Is maltose a disaccharide? Yes or no? True, false? What comprises maltose? Two glucose molecules: sucrose, glucose, and fructose, lactose, glucose, and galactose. Okay. And again, there they are: two glucose, glucose and a fructose, glucose and a galactose. Maltose, sucrose, and lactose. You can kind of see we have a bond that connects and forms between these. This is given a very boring term. It's referred to as a glycosidic bond. It's connecting two sugars together. But as you can see from the picture there are a couple different types of orientations. Alpha, where everything is on the same side, and beta, where items, molecules, are on the opposite sides. Of the two, it is much easier to break down alpha bonds. Body does it all the time. Very simplistic, very easy to do. Beta bonds are difficult. We don't generally have, as you can kind of see here, a whole hell of a lot of these enzymes. In fact, the only really one we have is lactase. If you're lactose intolerant, you lack sufficient, or you lack entirely, the enzyme lactose, okay, or lactase, sorry, to break down lactose. Well, if we eat all these beta bonds, if we eat a lot of foods with these beta bonds, do we digest them? It's partial digestion. Right? You can break off some, you can break up some of those bonds potentially, but not a huge amount. Bloated sensation, gassy. You ever been like that after eating certain types of foods? Because certain foods are very, very high in these beta bonds. That's where BINO comes in, right? Take BINO and their BINO gas. Right? It helps our body to break down those beta bonds. Again, because we lack those enzymes. And again, there's your example. Okay? There's your example of having insufficient enzymes to break down those beta bonds is lactose intolerance. You can do some stuff to kind of train your body into being able to handle milk, lactose. Okay. You can build up a tolerance to it, type of thing. So there's some things that you can do if you are lactose intolerant. But again, all of that lactose enters into the large intestine, and the bacteria is going to break that down. Because again, what's that bacteria doing? Breaking things down that we don't have enzymes for. If it shows up, that bacteria are going to love it. But in the process, man, it produces a lot of waste as gas, right? Excess air. And that's going to cause that bloated feeling. Obviously, that leads to flatulence, farting, right? And so if you are somebody who is lactose intolerant, if you consume a lot of that milk, you get bloated, you get crampy, and you get gassy. There you go. And then lastly, to top it all off, you get diarrhea. Okay. How do those bonds form? How does that mechanism happen? Well, it happens with basically a condensation reaction. Okay. Here's my two monosaccharides coming together, forming that alpha or ultimately beta bond. But in the process, I've produced water. Right? And that's where the condensation comes from. Right? So I've produced metabolic water in the process. And I just get rid of that. Okay? I just get rid of that water. If I throw water into that disaccharide, what do you think is going to happen to it? Boom, boom, breaking that beta or breaking that alpha bond there and getting me glucose and fructose. Okay, so that would be using water to break something down, and that would be a hydrolysis reaction. Okay. So if we went backward, we throw water into the system and we utilize it to break it down. In the watery medium is the enzyme. There you go. So condensation reactions are helping us to form glycosidic bonds. They can be on the same side, alpha, easy to digest, easy to break down, or we can form glycosidic bonds where they're on opposite sides, beta bonds. Difficult to digest, difficult to break down. We lack enzymes for it. And that can lead to some gas and bloating. Sugar comes in many different forms. Sucrose. I think on the next slide, I think I have a few examples, but sucrose found is, we can make it, but it occurs naturally in a lot of things. Honey. You can read all the examples there. And the concentration, the amount of sucrose in these will vary a little bit when it comes to all that ultimately. But just because it comes in a natural source, though, and that's what I'm trying to show you on that next slide. Just because it comes in a natural source, though, doesn't mean it can't be unhealthy for you. If you consume honey instead of sugar, you're still consuming sucrose. It's just that the sweetness level is so much higher in honey compared to your sugar, your white granulated sugar. You don't need to use as much. Agave, same damn thing. The agave, the sweetness level is way super high. So the serving is way low. But that's not how we utilize it though, right? You take that agave and you cover the whole piece of bread. You don't have to. You're consuming more sugar in the process. So just because it's natural doesn't mean it's better for you. Okay? It can be just as bad when you don't have the right serving size. It's all about serving size. You can see most of the sucrose in the American diet, like I said, we make it, comes from sugar cane or sugar beets. So it's, obviously very, very, very refined. Sugar in the raw or turbinado sugar, I just call it sugar in the raw because that's how we all know it. The fancy name for it is turbinado sugar. This is different. It's not as refined. This is what's made after the first pressing of the sugar cane or sugar beets. So it's not as refined. So it's a little bit better, I guess, in terms of not as highly processed type of things. Again, all these do are providing sweetness, okay, which helps to facilitate you eating things, taste, all right? They're not good sources of protein, obviously. They're not really great sources of vitamins, minerals, fats. They're just there for providing sweetness and obviously providing carbohydrates in the process. But if you're trying to look for sugars to provide you anything else, wishful thinking. I'm not going to ask anything off of this. I'm not going to ask you how many milligrams of niacin is in. I'm not going to ask that, jazz. But here you can kind of see, honey provides 64 calories. White granulated sugar, 49. So you can see just because it's, coming from a natural source, right? Here's high fructose corn syrup, right? It's devil incarnate right there. And you can kind of see, from a kilocalorie standpoint, a little bit more. Again, not a rich source of protein. 0 is pretty low. 0.01 is really low. Not a great source of vitamins, really. Obviously, a lot of zeros there. 0.0000s. Good Lord. These are not good sources for things. Great sources of carbs. I have a lot of grams there. Okay. But not much for anything else. I'm just putting this in here just to give you an idea that just because it means it's a natural source or healthy doesn't necessarily mean it's in excess. It is still a bad thing. High fructose corn syrup gets a lot of bad press, and deservedly so. It is something that we've created, and it has a ton of fructose molecules strung together. And it does a great thing. It adds sweetness, it adds longevity to something. So from that standpoint, it allows things to sit on a shelf for a much longer period of time. Okay, doesn't spoil. Can stay sweet. It's because we add it to process things, which generally are unhealthy in nature. They're just very calorie ridden, nutrient poor. These are the individuals that usually get blamed for all of that. And as you can see there from what I started, there's no conclusive evidence that the use of high fructose corn syrup causes poor health or disease. It's the totality of everything. Excess calories from beverages, soda, okay? with high fructose corn syrup contributes to an increased risk of everything. So it's just one, I mean, is soda a great source of macros? No. Is it a great source of vitamins and minerals? No. But what are these found in? What types of things is high fructose corn syrup found in? Processed foods. Processed foods tend to be less nutrient dense, very calorie dense. Okay. So if the vast majority of your food choices are coming from processed, then yes, you do consume a lot of high fructose corn syrup. But you're also consuming foods that don't have a whole hell of a lot of nutrients at all anyway. Very calorie dense. And if you're not really active, where do all those calories go? Around your midsection, right? Butt, thighs, hips, all the places that you don't. Okay? So it's only a part. It is only a part of the bigger picture, which is everything that you're shoveling in. Okay? Lifestyle choices. Right? It's not just one thing. If it was just one evil, we could probably decide to get rid of it. But it is a lot of different things. Besides sucrose being something that we can add to provide some sweetness, there are a multitude of other sweeteners that we can use as well. Nutritive and non-nutritive. Nutritive and non-nutritive. Nutritive provide some kind of nutrient. Non-nutritive don't. And we'll see that here in a second. Nutritive sweeteners can sweeten, and I have it underlined, and contribute some energy. How much? About 4 kilocalories per gram. That's a number that I would remember. Okay. And again, when these occur naturally in foods, like in fruits and some vegetables, it's okay, dude. It's all right. Perfectly fine. Okay. But it's when we add excessive amounts of sugars, nutritive sweeteners, to our food, that's where we get caught in excess calories, and that's where we get caught in overweight and obesity situations. The great thing is, and this is about the one good thing when it comes to us consuming less of, we do consume less added sugars now. Okay. And this has only been reinforced by the new label, which again started in 2020, 2019. 2020 was the drop dead date for it. I think it got initiated in 2018 or something like that. But they gave companies 2 years to change the packaging of the products. But you can kind of see, from 2-year-olds on up, 2-year-olds, I know. I mean, you can see they consumed about 150 pounds of simple sugars, and you can see 15 years later, that's gone down about 20 pounds, which is crazy to fathom when you think about it. Consuming 150 pounds. Hey, if you're a 150-pound person sitting there right now, think, man, holy smokes, I'd eat a whole me. What the hell? It's crazy. So if there is some light in this dark tunnel of overweight obesity, it is this. We do consume less added sugar. So something's happening. Okay? Something's happening. Because we are still consuming excess calories. That's what leads to overweight and obesity. So, it's not coming from this one little aspect. Again, just one little aspect. Even though this has gone down 20 pounds, obesity rates still go up. Okay? Still go up. And even from the old textbook that we have to the new textbook, which has the updated data, which I think I have. I've updated the data anyway, because the book was like 4 years old. But obesity levels have gone up dramatically, though. Right? They've steadily climbed every year. So even though one little aspect has gone down, it still goes up. Still got to figure out why people shovel too much. Here are the names of sugars. Again, guys, I'm not going to ask you, is dextrose a type of sugar? But you can kind of see sugar comes in many different names. Holy smokes. Brown sugar, tasty. Agave, there it is. Fruit juice concentrate, confectioner sugar, xylitol, sorbitol, mannitol. I mean, holy smokes. There's corn syrup. There's high fructose. I mean, good God almighty. I think there's like 80 names or something like that associated with sugar. It's hard to just read a label and discern a lot of times if you're reading something that's sugar, unless it says sugar on the end of it. Okay. Or people don't realize agave, oh man, agave is really healthy for you. It comes from a plant. It does. But when you consume excess consumption of, it's bad for you, okay? Just because it's excess. That's why, again, having the added sugar component on a food label has been really helpful in getting that consumption of sugars down 20 pounds. And that helps a lot of young kids who are very overweight and obese. Just getting rid of that added sugar component really is enough for them, and healthy lifestyle, activity, and again the totality of. But I have this one friend, and her son is very overweight. Okay, very overweight. He's 8 or 10, very overweight, and just in the past, I think she said 3 months, he's dropped like 20 pounds. That's freaking awesome. And the only thing that she says that they've concentrated on doing is removing the excess added sugar out of his diet. One change. Keeps active. Okay, still eats, somewhat healthy now, at least since the beginning of the year. But just doing that one little thing has been so helpful for him. That's why it's important to kind of read that label, figure out. The other type of sweeteners we have are alternative sweeteners. Alternative sweeteners can be kind of all over the place in terms of providing kilocalories. Some of them do provide kilocalories, and these alternative sweeteners do. There are some alternative sweeteners that don't supply any energy, don't supply any kilocalories. The ones that do supply calories, so they are still kind of in that nebulous region of nutritive. Okay. They are sorbitol, they are xylitol, they are mannitol. Okay. If you've ever eaten low sugar gum, you've seen it. Okay. You've seen it. They do not promote dental decay. That's a great positive for them. But our body doesn't absorb them completely. For these sugar alcohols, they can supply around 2 kilocalories, which is different from the 4. So if you're looking at a way to still have some sweetness to something, but not get all those excess calories from it, sugar alcohols are a great choice. Okay, you can find them in the grocery store. If you consume too much of them, these calories can add up. So if you do eat a lot of gum, you can still be eating a lot of calories. Okay, especially if you eat 10, 15, 20 pieces a day. I mean, this comes in, there's like 40 in this thing. Okay, I mean, yeah, I mean, this is 2.3 grams. Okay. 5 calories. Okay. These are bigger pieces of gum. Okay. So a little bit bigger than the 2 kilocalories. Right. Not fully absorbed though. So we don't get the full Monty in terms of kilocalories. We get a little bit less. Fantastic. It can cause diarrhea though if you consume excess. And you'll figure that out right away. Okay. Some people, it just takes a little time for some people to get used to them as well. And you don't consume as much sugar, or I'm sorry, as much gum, but that's okay. Not as much kilocalories involved. But it can cause diarrhea, just FYI. Your non-nutritive sweeteners, these are your stevias. Okay. Your sucralose. Right. These are the ones that provide, as you can kind of see over there in the column there, that last column, 0 kilocalories. So these are your non-nutritive sweeteners. Okay. Provide no nutrients. Okay? No nutrients. No calories. No nothing. As you can see, aspartame is nearly 0. It's like 0.0 something. I can't remember off the top of my head. But still relatively 0. So we just put them all to 0. Okay. You need these in very small amounts. I mean, where's sucralose and stevia? You can see sucralose and stevia. They're Splendid, Sweet Leaf, Truvia. Okay, some name brands that you've probably seen. I mean, 600 times sweeter than sugar. So you don't need a whole hell of a lot to give you that same sweetness. Okay, stevia anywhere between 200 and 400. Atavane, 20,000 times. Holy smokes. Good Lord, that's crazy. I mean, neotame, 13,000. Saccharin, 300 times. I mean, so you could see, I mean, these are very, very, very potent in terms of sweetness. So you don't need to add a whole hell of a lot to it. So you're consuming less sugars. So you don't crave them as much later on. Okay. Again, no energy. Okay. No energy. And a very small amount is needed. Now, of them, I don't get into every single one of them. Of the 4 majors here, aspartame, saccharin, sucralose, and stevia, of those 4, really only these 2 are heat stable. And what does that mean? Only these 2 are allowable to be used as in the cooking process. If you put saccharin, sweet and low, or aspartame, NutraSweet equal, if you put either of those over heat, your dish turns black. Right? So if you want to get out of cooking, there you go. Add that to your dish. It'll turn black and it'll stink like hell. Okay. Sucralose and stevia are the only 2 that are heat stable, which means you can add them to your cooking process. And when you heat the dish, it doesn't destroy it. It will vary though, right? I mean, you can see the sweetness level is different from sugar. So because of that, the amount that you need will vary quite a bit. So if you're somebody who's just going to start cooking with it and do a 1-for-1, stevia for sugar, that's not the case. It's different. Okay. Those links that I gave you in one of those first couple lectures, lecture 1 or lecture 2, chapter 1, chapter 2, I can't remember. They've already done a lot of the legwork for you. Okay. And even then, you may have to tweak it for your taste palette. So these non-nutritive sweeteners are safe. They're safe. Okay. As we all know, our government would never lie to us. So we assume everything's on the up and up, right? Of course we do. Wink, wink. But there are some aspects of these non-nutritive sweeteners that aren't best for certain groups of individuals. Okay. The biggest one is going to be phenylketourics. Anybody who has PKU. This is a simple blood test. It's done in utero. Mom gets the test to see if she has PKU, if she has phenylketonuria. She goes on a specific type of a diet while pregnant, goes on a specific type of diet, while she's feeding said creature. And then that child, as it starts to get introduced foods, will be introduced foods and avoid foods that don't have aspartame in it. Okay. Aspartame has phenylalanine. Okay. Phenylalanine is an amino acid. These individuals cannot take it because they can't break down phenylalanine. And phenylalanine will accumulate in the fat that wraps around your nervous tissue. The body's like, what the hell is that doing here? mounts an immune response against it. Okay? So if you're somebody who has PKU, and again, it's a simple blood test. Okay, it's part of the prenatal screening process now, right? In every state, which wasn't the case. Missouri was one of the last ones to do it in 2000 something, 4-ish, 6-ish, 2006, 2004, somewhere in that time block. I can't remember. But not every state in the union used to do it. So, but now it is done in every single state because it's something that can easily avoid, cognitive development issues, anything along with brain and trying to get brain growth to happen properly. So it's something that can be avoided. All of these non-nutritive sweeteners have an acceptable daily intake in ADI. I don't get into that. Okay. You can read the back of all of those labels and get it. If you're curious, there's a link right there that takes you to the USDA website there, and it goes through all of the nutritive and all of the non-nutritive sweeteners, and it gives you all of the ADIs and all of the breakdown for it. So if you're curious, you can go there and read a hell of a lot more on it. So benefits, if I was to think of a potential short answer question or essay question on Unit 2, I would maybe ask about sweeteners and how the body handles them, if they break them down effectively or not. What would be the point? What would be a drawback of them? So, these couple slides, it wouldn't be worth a lot of points, maybe 4 or 6 points. But here are some benefits for it. Again, I mentioned it earlier there. It does help to prevent tooth decay. Okay. Studies have shown that xylitol actually helps to prevent the form of dental cavities, dental caries. It helps to control diabetes. It does that because these sugar alcohols have a much lesser effect. Non-nutritive sweeteners have zero associated with it. Your body doesn't absorb it. It stays in your digestive tract, boom, right out into the toilet. Okay? Helpful with weight control. Again, 0 calories. If it provides 0 calories, 0 calories. Again, whoosh. It gives you that pleasant taste. It gives you that sweetness, but it doesn't give you all of the excess calories in case you are that person who does love to eat the sweets. Drawbacks though, again, stability issue, heat stable, there's only the 2. All the other ones, it breaks down, can have to affect your baking practices. Excuse me. There can be, the first 2 to me are linked together. If you consume a lot of beverages with non-nutritive sweeteners in them, like soda, a lot of sodas now come with non-nutritive sweeteners added to them. That could potentially replace something that's more healthy. Low-fat milk is the example that's generally given. Okay. Children aren't to go on a diet unless they're excessively obese. Diets in children don't generally mix because that does 2 different things. One, you could not get enough calories. Kids need a lot of calories. They're growing. Okay, they're actively growing a hell of a lot. And if they are consuming a lot of foods, beverages, with this non-nutritive sweetener in them, or hell, even food in that, you run the risk of limiting calorie consumption, which can affect growth of that individual. Diets in children also is where eating disorders can start to rear their ugly head. So you don't want to do that as well. Okay. Proper amount, exercise, fantastic. You don't necessarily worry about calories per se, as long as they're having a nice normal serving size, have servings of fruits, vegetables, lean protein, and they have activity involved. But we'll talk about kid stuff later. Here's some facts here on it. Here's would I ask about anything on here? I don't think so. I don't think I'll ask anything in terms of these on the exam. If I do, there may be like one question. If I did ask, I'd ask one of those probably. But 5 milligrams for each kilogram of body weight. How do you get kilogram of body weight? Just divide your body weight by 2.2. And that gives you kilograms there. I mean, what does this mean? If you're a 150-pound person, you would be consuming about 9 to 12 packets a day. That would be the allowable there when it comes to saccharin, is what that generally means. If you're a 150-pound person, it's what's considered safe, not smart. 18 to 19 12-ounce cans of soda with aspartame in it. For a 150-pound person to consume the safe amount of sucralose, that's about 6 12-ounce cans of drinks with that. That's what, I mean, I think the book gets into it a little bit, and it says that you can consume like 18 to 19 cans of soda, and that's considered safe. I guess it's considered safe. Is it considered smart? I can't say what I would really like to say, because then somebody will complain. But hell no is the nicest way I'll say it. Okay. 9 to 12 packets of saccharin a day. I mean, is that the safe amount? Yeah. But do you need to consume 9 to 12 packets of saccharin a day? I mean, if you're consuming, 9 to 12 packets of sweet and low, I mean, good Lord. That's a crazy amount. That's a really crazy amount. If you're consuming that, hopefully that's just in the morning, at least with your coffee, I guess, right? And you don't do any more the rest of the day. Any more sugar the rest of the day. There you go. You're done for the day. But you can see how it can add up. It can add up really quick, especially when you start to add this up with your overall dietary profile that you're consuming.